All right, well, let us get started. Thanks everyone who is out there for tuning in tonight for the Sheridan College Museum of Discovery Science Lecture Series. My name is Scott Newbold. I'm a member of the biology department at Sheridan College, and I help coordinate the lecture series. And we're grateful to the Sheridan College Foundation and the Life Science Department for supporting these lectures, and to all of you who have been tuning in over the years, either virtually, but mostly in person, and continue to inspire us to keep this long-standing series going. We love having these folks visit and share their insights with all of us. Before we start tonight's lecture, just one announcement that there is a final lecture in December. That date is Wednesday, December 9th, also at 7 p.m. And Vikram Chhatray from the Department of Molecular Biology at UW will be zooming in to talk about his title, Can We Save North American Forest from the Effects of Climate Warming? At the end of tonight's talk, we should have some time for Q&A, and so there's a box at the bottom where you can submit a chat or a Q&A question so that we can, I can read those out to Ivy, and then she can respond during that session. So with that, I'd like to introduce Sarah Mentok, who is here. She's the Executive Director of Science Kids and has graciously offered to introduce the speaker tonight. Thanks, Sarah.
Thank you. Right. I rarely use the term serendipitous, but that pretty much sums up how I met tonight's speaker, Dr. Ivy Merriot. On the day of the solar eclipse in 2017, my family and I were driving my favorite Wyoming back road on our way home to Sheridan. The Lost Cabin Road goes over the Bighorns and winds its way through the loveliest Wyoming ranch land. We had stopped at the Norwood International Airport, an ancient rickety metal outbuilding big enough for only the tiniest single engine plane. Another car had stopped there as well, ostensibly like us, to snap a photo. We were chatting away with the driver when Ivy popped around the corner of the building and exclaimed, "Are you from Sheridan? Can you take some of my books there for me?" Which I did. That level of openness and trust is rarely found, and I believe it's integral to how Ivy approaches her life and work. Ivy's life is difficult to encapsulate in just a few sentences. She has taught physics and astronomy at NASA, as well as the National Teachers Enhancement Network, and brought the Hands-on Universe program, which was out of Berkeley, to teachers throughout the Mountain West. She has taught at public, private, and online schools. Ivy has also operated the large telescopes at Kitt Peak, which is in Tucson, and was one of the creators of Stars Over Yellowstone. I'd love to hear more about that, Ivy, by the way, the Stars Over Yellowstone. Ivy has a master's in history of science and a PhD in American and Native Studies both from Montana State Bozeman. Today, Ivy researches ancient astronomical sites and shares her findings through articles, public talks, and books like this one, which it's a wonderful book, Star Circle, and you can find it at our local bookstore, Sheridan Stationery. Please welcome Ivy Merriot.
Thank you, Sarah. Yeah, that was a serendipitous day, all right, so fun. It turned out, actually, my husband's a pilot, so he was stopping because it was an international airport and had that one little hangar and the whole huge landscape of nothing but beautiful ranch land.
Oh, yeah.
Anyway, good day.
And that day was just charged with so much, yeah.
Yeah, we're coming back from the eclipse. Yeah, definitely. Yeah. Well, off to the sky. So I can't really see when I ask you guys how many have been to the Bighorn Medicine Wheel, but I'll assume a bunch of you have, and there's probably a bunch more that want to. It's on their list, or they probably wouldn't even come to the talk. So here it is on probably an autumn morning. This is probably September. As you can see, it's super high, 10,000 feet. I'm just going to give you a few pictures just to let you get used to the feeling. This was my first trip up. It was 80 degrees down below in the valley. And this is what I met when I was up there. And I had to put everything I had on. And I usually have a lot of warm stuff, and I was still couldn't stay out there very long. Here's another October view. One of the first snows, but you can see how those spokes really stick up. The wooden posts are not part of the original wheel. Those are just put there to protect the wheel from people just trampling across it. So here is a longest day of the year photo. And that's a big snowdrift. You can't drive up there, but it doesn't keep some people from having fun getting there. And we have gone up. You'll see the photos I have of the sunrise on the solstice. We're on a day just like that with this, where we had to carry our gear over the snow and try not to slip down the mountain. So what we're going to do tonight is compare two complementary techniques for keeping time. One is low altitude, that's the cute little petroglyph, and then one is super high altitude, the medicine wheel. And the reason I said design rather than just medicine wheel is it's this design that I studied. There's lots of other wheel types, and I'll show you those to you. But this is the one that we found so much astronomy related to it. And then this petroglyph was found later very serendipitously. So you don't have to read this, and I'm not going to, but a lot of us think we just get time from our watches, from the calendar. That's it, right? There's just one time. There are many, many times. This is just the start of it. And almost all of them are culturally constructed. Now, that doesn't mean that the culture doesn't take into consideration the sky and astronomy, but there's a lot of them to take consideration of. You can base it on the moon, you can base it on the sun. So when you look at these sites, you don't go in there just knowing what time is based on. You certainly don't try to smash your calendar or our present calendar onto any of this, but you let it speak to you and see what you can learn. And I can tell you without any hesitation that I learned more from these two sites I ever learned in all the physics and astronomy and the teaching of astronomy and all of that. There is more to learn from these, and I'm very appreciative of that. So why would you even care about time? Well, over 100 years, you know, there's all these things you've probably already read them by the time I'm saying it. But, you know, our whole system of trade and banking and keeping track of each other, right? We need time for that, both hours, seconds, and calendar days. But over 10,000s of years, here's the part I'm really interested in, is because these are the sky watchers, and this is their knowledge they hand down to the next sky watcher and the next sky watcher. And they get together, you know, travel to get together with sky watchers from different places to see what they see and how they've connected it. What designs have they come up with to figure out their latitude is a huge thing. So when you change latitude, all of a sudden, a lot of things, the way something would be designed at one latitude, if you put this wheel, which I'll show you up in Canada, this design has to change. It shouldn't stay the same. If you have a wheel that looks the exact same, no matter what latitude, it's probably not astronomical. I'll tell you why later, possibly. Anyway, so as you can see from what I wrote there, if you can track these changes over these long periods of time, 12,000 years from now, our nice June and July are going to be winter, and our Decembers are going to be summer. Of course, this is North America I'm talking about. So the changes that are going to take place in those 12,000 years as the plants and animals move and change, and the water moves and change, and the ocean heats up in different places, you've got a lot going on. Well, it's your sky watcher that's going to give you a clue where you are in that cycle. Now, the calendars we have on our wall right now, they don't tell you that cycle. Reset, spring equinox, boom. They always have it the same similar day. But the real calendar of the sky, oh no, that's slipping. About every 66 years it slips by a day. So let's start with Sheridan, since this is for Sheridan College. 1958, excavation of the wheel by the Sheridan chapter of the Wyoming Archaeological Society. And if anyone knows these three people, and if any of those three are still around, I would, oh, there's four. I would love to talk to them, or anyone else who is on that dig. There's very little I've been able to get hold of. But the things I have been able to get hold of shows that these guys did a real quality job, because I've compared a lot of pictures of the spokes of the wheel from about 1905, right up till you'll see one that was taken this summer. And those spokes, I actually can't tell that they've changed. So that's saying a lot, because, there's the thing about the Boy Scouts cleaning it up. Well, I kind of show you a little how that works later. But anyway, the excavation didn't really find anything they could date, just broken arrow points and small things, beads and stuff. But they did find some charcoal that they didn't date at the time, but later dated to be really old. But it wasn't part of a hearth or anything, so they couldn't, they didn't really talk about that much. But they did find some wood in an upper cairn, and it was dated the 1700s. So that's kind of cool, because it shows that maybe that cairn hadn't been rebuilt for a while. And then, I'll tell you about how the astronomers dated it later. So these medicine wheel categories, you guys probably can't see my pointer, but look down about halfway to that the one that looks small and smudgy and dark on the right, says Majorville. That's actually one of the bigger ones there. I think it's because there's so few of them that John Brumley made it small. I don't know. Anyway, that's the kind that the Bighorn Medicine Wheel is and the Majorville Wheel is. And there's about 4 others, one of which has been kind of lost in the last 50 years. And I've been searching for it every summer. It's quite fun. But anyway, here's just a map of where you guys are in Sheridan. I'll do a bigger one for everybody that doesn't come from Sheridan, so you'll see where the bighorns are. But these are mostly the bighorns going through the middle of the picture. Bighorn Medicine Wheel up to the left, 10,000 feet. Medicine Lodge Creek is where the rock art is. That's at about 5,000 feet, so about half as far in elevation. Okay, here's your bigger picture. Yeah, it'd be nice to have some kind of pointer on these things, wouldn't it? Okay, the Bighorn Medicine Wheel, and realize everything you're getting in my talk is from my research, my opinion after my research, and my data from my research. So if you don't agree with any of it, that's great, and you should actually tell me why and stuff, because I love to learn. But from my research, it looks like the wheel was most likely built by ancient Shoshone sheep eaters, but have definitely used it. So the Blackfeet have told me that they've come over and they actually check it against their own medicine wheels, just to see if everything they think is going on checks out with this one. And they've been doing that for a long, long time, but they didn't build this. As far as they know, it's always been here for them to come and check against. So here's one of the first astrophotography pictures. It's the Milky Way bubbling through the sky. I have this in here to let you realize that, these 2 kinds of techniques of timekeeping that we're comparing. This one, the wheel, it needs this horizon. It looks out across the horizon, and the sky, the huge sky, is a huge part of it. Part of it also mirrors the sky above it. And so together, now Lovell, that's that bright city down there that looks like LA, but that's just because the camera took in the light to be able to pull in the stars. The stars are actually brighter than that when you're up there, and Lovell is much dimmer than that. Just gorgeous. So the oral history we do have of the wheel comes from a lady who was 115 years old when she was interviewed, a Greta. Her name meant, I found 2 pictures of her. One of them, her name was Woman Under the Ground, and the other one, her name was Crosses a Stream. Both of them said a Greta, but it was just, what her name meant. And then another Crow Indian told me that there was an old woman that's very well known that lived with the Crow for quite a while, and we're trying to figure out if that was a Greta. The Greta, all of her people died of smallpox. She talks about the teepees just being full of dead and dying. She lived through that. She lost her children, her husband, her parents, everybody. And she wandered by herself for a long, long time. And I think it was about when she's in her 60s, she joined the Crow. She probably thought she was kind of old enough. It'd be nice to have some help. I don't know. But anyway, and so even then she probably lived more than 50 years living with the Crow. So think about that, especially people's lifespan back then. She might have easily lived through 3 generations of kids calling her grandma and hearing her stories. So the Crow carry a lot of knowledge that could have come straight from her. And it's part of the research we're still doing to figure out this grandma to so many. But at anyway, I used to think that the Crow tried to take too much ownership of the wheel. But now I don't at all, because for one thing, if a Greta adopted them, they adopted her and she shared her stories, then that's a human to human. You've also got the land itself. And if you know the story of No Intestines and praying at the wheel of where to bring the Crow people and where to be their home, basically the stars and skies themselves gave this home to the Crow. So I'm very humbled these days about not, being too academic and being more open to the fact that things happen in all sorts of ways. Another woman who loved the wheel and spent time, I guess I didn't tell you any of Greta's actual stories, maybe I will as we go on here, was Jessamine Spear Johnson. And she wonderfully, thankfully, she was a photographer, and her family owned a ranch that she later pretty much ran. And this is her bringing people up to the wheel, and she'd take people up there. And of course, it was a long trip, and so you had to have supplies and hang out and enjoy it. But she had a really deep respect and loved it. And thankfully to her, we can compare a lot of older pictures to the ones now to see if it's changed at all. Here's one of her pictures. And look at the photography there. It's faded in the background, yet nice and crisp, in the middle ground. Now this wall was probably built to keep out big animals. Well, actually, I'm sure it was. But what the probably is that there was cairns only about 5 years before they built this wall. There were cairns outside of the wall, beyond this wall, that are no longer there. So I have to wonder if they got dismantled to build this wall, which is really bad for astronomy, because you could use those cairns to make a longer sight line, and longer sight lines is always what you want. So if you're not familiar with this side of the wheel, the way people come up now is actually from the other side, but there is an old trail, 8,000 years old on this side. Actually, they're all over the Bighorn, so there's nothing new about that. But anyway, very steep, but you can get up there. And those posts you see right under that arrow, the Bighorn Medicine Wheel, are actually the wood posts. That's not the wheel as it would have been in other times, but it does show you where it is. It's on top of the world. You've got a heck of a view. Here's an aerial view from this year. Now, when I started my work on the wheel academically, I studied it before then, but when I decided to go get a history of science degree, I thought, wow, it'd be really neat. There's got to be more astronomy to that wheel because it's so complex. And they'd only really found the solstice line and a few star alignments. So I really wanted to study it, but my committee chair said, oh, why would you bother? A wheel can point to anything, and everything could be learned, has already been learned. Well, anyway, let's see if I can get this to work. There we go. You know what else can point to everything is a compass. Yet we use it all the time to track everything about navigation and where things are. And so little by little, I had to convince him, which was great. You want people that you have to convince. But anyway, as you look at this picture too, check out that walkway, is totally new. And the fence is new. So when archaeologists look at this, say 500 years from now, they're going to have to sort out what came first, what came second, to if they don't still have records of what's done now. So we're adding to the wheel, and also there's a sign there that says walk left. There isn't anything about this wheel before that gave any impression of anyone walking any certain way or even walking around it. That indentation you see over to the right, that's what's left of where the fence was. So anyway, it could be, if it was ancient Shoshone, it might not have been exactly how Plains Indians would interact with the wheel. Not that this wheel cares. I think it's just fine with ceremony being done whatever way people want to do ceremony. Okay, so here's a sky watcher who we know used these kinds of things. That's his station, SUNY Sun Station. And this was 1905 when people could, walk right up to a Indigenous nations sky watcher and see if they'd share any knowledge. And he did share how he, tracked the sun. that plank of rock you see inside that Zuni Sun station actually had or has a sun symbol on it. Now, if you look up at the Bighorn Wheel, when they did that dig in 1958, they found so little, but there was a mining town not far from this. So possibly if there were any things, they'd already been cleaned up by the new people coming in and interested. Now, here's another way a wheel is also used now. And this is a wonderful fellow, Mao, and I don't know how to pronounce his last name. He taught the Hawaiian navigators. When you hear all those things about the Hawaiian navigators, you know, going around the Earth, which I just watched a great Zoom on just a couple weeks ago. And I also saw them in Hawaii years ago when they were getting their schools started on it and stuff. But at any rate, here's the guy that taught them. They had to go over to find someone who still knew how. And he's got a wheel, nothing fancy. It's not hand carved that I can tell or anything. It's pieces of coral and little lines between it making segments. So how his wheel works is that you have to obviously know the names of the stars and you have to know their positions. That's all those corals laying around the wheel. And you have to know their rising and setting, but you don't really memorize it. Instead, you have stories, and every story about how a star moves is what guides you through. And when one young person, even after he was trained, was just a little bit afraid to get in the boat, this is recent history, 20 years ago or so, was afraid to get in the boat, Mao told him, actually he was in the boat and they were out in the water, excuse me. And he was just like, can't we pull out our GPS or something? And Mao just said, trust your ancestors' stories. Remember those stories and trust them, because those stories will tell you how those stars move. Well, when you're out on the ocean, you watch to see when that star comes up, but then it's not just going to stay in that position. It moves because the Earth is spinning, so the stars are going the other way. So you have to have those stories to tell you how each one of those stars is going to move and where you're expected to find it, at what time of night, what time of year. So anyway, evidence that people can use circles to do tremendous navigation by the stars and can divide their sky up with these pie-shaped segments. Now this is a little deep. I don't know. This might be a good time to get tea, because this one I've never tried to describe to anyone, so I don't know if it'll come across. But if you're a sky watcher, well, let me take it another level. If you drive a car through a town and you don't use Google, you don't use maps on your phone, you kind of keep a map in your head. Oh, I know how to go this way and around that corner. You don't have to be at that corner to already visualize which lane you're going to get into, how you're going to turn. You've got that map in your head. Well, believe it or not, this is how a sky watcher sees the sky. It's not just dots. They know where those stars are going to be and when they're going to be there. I bet you guys, oh, I can't use my cursor. I bet you guys can figure out that star in the center that's kind of not quite in the center, but as time goes on, it makes a little circle. This is over a 24-hour period. Sorry, I should have told you that right off. That's Polaris right in the middle. And a sky watcher could just tell you all those stars right out. It goes somewhere, it's always fun to go somewhere where it's cloudy and there's one star sticking out and say, hey, there's Arcturus. And people say, oh yeah, like you know that was Arcturus. But you do, because you know where they're supposed to be in the sky. So if the clouds break open, plus you notice those were different colors. So the colors help you too. So there is another story more recent than Greta. And this is Cudir, a crow fellow who guided a lot of people up to the wheel. And this H.H. Thompson also took a lot of pictures of the wheel. I haven't been able to find out too much about him. So if any of you guys over there in Sheridan know, I'd love to hear more. Because he ended up on a few of these expeditions with different people too. But anyway, Cudir, I'm kind of using it as an example of the burnt face story. Burnt face was a crow story. Actually, it's kind of a pan Indian story in some ways. But at any rate, the crow part is that Burnt Face had scarred his face and left, I don't know if his teeth, he left and wandered by himself for a long, long time up in the Bighorns, and possibly could have built quite a few wheels. For what reasons, I don't know, just ceremonial, or whether he's trying to keep them for navigation, I don't know. But at any rate, he was up at the Bighorn Medicine Wheel when he had a vision, and the little people told him he needs to go back to his people. And and he needs to build a wheel. And when he went back to his people, and there's way more to the story, but when he went back to his people, he went down to Fort Smith and he built that wheel on your right. Now, right on, go, oh, those are two different wheels. Oh, not at all. For a few, go down low, and then you have a different horizon, and he's got a little bit higher in latitude. Your rays sticking out, they can stick at the same, they can look at the same things like A, B, C, and D, even though that angle isn't the same. And in fact, once again, if it was the same, it probably wouldn't be astronomical. It would be just somebody going, oh, I'm just going to copy this. But this shows me that Burnt Face understood how the stars and the medicine wheel work together. Oh, and the sun, because he's got the solstice alignment in there. Because he went and built this. So that's part of the astronomy that isn't really told too much about Burnt Face, but that's what his wheel shows us. John Eddy went there. He'd heard already that there was a solstice alignment there. He didn't like come up with that. He actually just decided, hey, somebody should go take some measurements and check it out. So he did. And it actually made kind of world fame because they were talking about it being a Stonehenge. And so when I went to Stonehenge, I had to say, hey, you guys got a medicine wheel over here, just to go the opposite way. But at any rate, he did some alignments. That's his daughter, Alexandra. And this is what he came up with. You don't have to even pay attention to all of this. I know it looks crazy. The first time I looked at it, I just went, oh, whoa, am I supposed to make sense of this? And I even knew stars then, and it still seemed crazy to me. But I'll give you another one in just a sec that's easier to comprehend. But anyway, this is his. He figured out a few things. That's all you need to know about that. He figured out a few things. And then another fellow named Robinson came along. He never went to the wheel, though. Eddy did. Robinson did it all through math and that. And I got to know Robinson when he was in his 90s, right till he actually died. And we were working on something up here, which I won't be presenting today. But Robinson thought the stars might be higher when they viewed him. So he had a little bit of different idea in it. And then he came up with a different date because of it. But Eddy's dates, the ones that are based on those red lines, put the wheel about at 1700. And you've probably heard a lot that it might have been built in 1700. Well, from all my research, which is 14 years of it, and my deep love of this subject, no, this was definitely not built in the 1700s. All the Indian nations would know if it was. They would have all known when it came. Their histories, oral histories go back farther than that. All of them do. This was built earlier, but what we do have is maybe the last time it was aligned was the 1700s. That's when that piece of wood was in the cairn that the 1958 team dated. And so a cairn was built at that time, and someone was still using it, hiding from the wind while they watched the stars. So yeah, I'd say that, put that in your notebook, in your notes. 1700 is not an origin date. That is it was aligned. Doesn't mean the last time it was used, because I use this and I don't move the rocks around. So people could still have kept using it long after that. Now check out that solstice alignment. That's the one that goes from the outer cairn to the right, through the wheel, and to the sun. Well, notice how it goes right to the sun. Well, when I had, this is actually my father that drew this for me. When he drew this, I assumed it still did the sun. And it wasn't. I set up a good friend named Emil who loves to go to high mountains, and he goes to Mexico and gets up on top of pyramids and watches astronomical events and stuff. He went up there and kept trying to get pictures of that alignment, and he came back and said, "Oh, I'm sorry." He said, we couldn't get it to line up. He'd stand on this side. You know, he didn't want to go too far off alignment, but he tried just anywhere in that cairn, near that cairn, and could not get it to line up. I was overjoyed, because that means that wheel is older than we thought. And it also means we can date it. Now, Eddy, the fellow you just saw with the theodolite and his daughter, They just said, oh, it's pretty close. It's about 1.5 degrees. 1.5 degrees would be terrible for these sky watchers. They can do so much better. So I guess how far it's off. It is about 1.5 degrees off, but that's because of its age. So the first time I'd gone there, I'd looked down that line just in the daytime, and I saw this knob at the distance. I'm like, what the heck is that? But it took about 4 years for I finally climbed all over and found that. And when I found it, oh my gosh, it wasn't just a knob. It had a hole in it. And this is not a cairn. It's not rocks setting there. This is rocks that are totally embedded. But they do have kind of layers that you can see are weathered in that. So whether this hole was made on purpose or there's a bunch of hoodoos up there with holes made by the wind. So this one might have been just modified a little bit so they could use it. I don't know. Anyway, it looks right back at the medicine wheel. I know you can't see the medicine wheel. You'll have to trust me. It's right in that meadow, right at the top of that meadow thing. And then this is Amiel. He went on this trip. But why I want you to see this is you see that there's only sky behind him. Look how low the horizon is. And this is only going down this a little bit. The wheel's quite a bit farther down. And so the sun could definitely come through that hole, come right down that solstice alignment and hit anyone standing in that solstice cairn. Okay, but if it did it, or could it do it? You know, it's a nice idea. So we went up, we got this huge 6,000 lumen flashlight. And we thought we're going to go up there and put it in that hole and go back to the wheel and see if you can see it. We didn't need to at all, because once we set up at the wheel, you could see the light, not the sun, because it moved over, as you'll see in a minute, but you could see the light through that hole actually pretty easily. So yes, the sun could have shot through that hole back to the wheel. I think I just showed you that again, just to show you this alignment from that cairn that's sticking down on the bottom right. Follow that line to the sun. And we just kind of threw in any landscape there, my dad did, but it's kind of nice. There is a little notch of something right in line, and that there would have been a hole in that if we would have made it. I just wanted to give people some way to look at this. Not sure why that's dark. So this is actually solstice morning. A few years later, we're going to do that hole in the rock thing and actually put this to the test. And we're waiting for sunrise. It's already pretty light. Now the next picture where the sun comes up, it's going to look dark. That's the same one you saw earlier. It's going to look dark, even though it's after the other one, because kind of that's what it does. Not as much to your eyes as it does to the camera. But at any rate, right before this picture, because the sun's actually already up too far for a sky watcher, camera almost can't catch that first glint that a sky watcher can see. But we caught that first glint and measured it to know the distance. Okay, this is really weird. I have never done this before. So you guys are an audience I'm checking this out on. Okay, so that's the wheel. That's the wheel from this year. And I just kind of removed everything so we can kind of see stars and see how it works. So we've got this solstice alignment that you saw in that little graphic. And then we got where you look through it. See how it follows the solstice line through the center, which becomes very important. Greta talked about that center as being, well, she called this a sundial. That's a translation, English translation of what she called it, but sounds like something that tracks the sun. And she also called the person who would go sit in there during a ceremony, the one she talked about was her wedding actually. She called it the sun chief, but once again, we don't know that word chief. That's how that was translated. So it could just be a leader that had something to do with the sun, or a shaman. At any rate, the important thing to me as archaeoastronomer is that we have a line going right through that center, right down that solstice line, and to that rock, to the sun, where it would have been then. And you don't have to know everything on here, so don't let it freak you out. Also another good time to get a cup of tea if it's if it's too scary. So this is my graphics. This is my level of graphic expertise. So anyway, down at the bottom in blue, is the medicine wheel, and that little blue one is just that solstice cairn. You're looking out at that same alignment that I've been showing you. That's the rock with the hole and where the sun could have come through. There's nothing to have kept it from coming through about 5,000 years ago, 3000 BC. The way I got that date is, you see the rising sun in 2017. You know, we measured the distance between the two. And in this, we had to use some trigonometry and stuff, because you have to get it back down to that blue line, which is called the astronomical horizon. So when you put this indigenous science in Western science model, which is what I'm kind of doing here, then I had to play with it a bit. But I could tell it was at least near 3,000. It could have been older. So I was very ecstatic. Oh, okay. So that one method, sorry, I thought a different slide was coming up. My research I did in my dissertation, this is kind of your backup. There's another method for finding that date. That would have been, what I just showed you would have been cool if that's all we found. This is great. We could date the wheel. We've got really good measurements. There's a rock 4.3 miles away. So just get a really nice lineup that far away. With that distance, it wouldn't matter if somebody moved some rocks in that spoke. You know, you've got too much going in that distance to help you with the measurements. Really easy to see the sun. You know, there's no problem here with the astronomy. It would all work beautifully. But this isn't the only way it can be dated. And so this is what blew me away. Something I had actually done earlier, but never pulled it all together until after we did this. So this was the research earlier. Found that, this is my PhD stuff, we found out that this wheel actually mirrored the stars. A circle of stars, but not any circle of stars. Because as many people could say, there's a lot of stars up there. Couldn't you just pick a circle of them? Yep, you sure could. This circle is a very special circle. Is that all? Oh, there we go. This circle reflects a circle that's called the Procession of the equinoxes. Oh, shoot, you were supposed to see that one. Can I make it go away? So this is the precession of the equinoxes is what gives you that winter in summer 12,000 years from now. And it's a little bit complicated, so I could show it to you afterwards if anyone's interested. I have some slides ready. But for right now, all you need to know is that our Polaris, it's strange it's even called Polaris because it's not the only pole star. I'd like to know what our star was called 2,000 years ago when it wasn't the pole star. I guess I have to go look at some Egyptian or Chinese stuff to figure that out, or maybe ask an elder that might tell me. So anyway, you see the little dipper up there at the top of that circle, plus 2,000 years. That's right now, that's Polaris. Moves over to the minus 2,000, and then the next star that hits it is called Thuban. That's going to come up again. That's why I want you to notice that one. And that's about the pole star we would have. If that dating I showed you works, that would be the pole star at that point. Okay, well, this is kind of cool stuff. And I just found it because it's mirroring it. It's a pattern. Nobody needed to tell me, although I guess I can't be, I need to be a little more humble. An elder did give me a ceremony, and until I did that ceremony, I couldn't come up with this. And partly is because I didn't get that it was mirroring it. The stars don't match up. It's like taking your two hands. They look a lot alike, but if you try to put them together like this, you can't get the thumbs to line up. You get big fingers. You've got to mirror them, and then they line up. That's how this was, is I struggled and struggled, and that ceremony helped me learn a lot, and I have to give it credit. So what happens though is look at that line. Even though Polaris is on that circular line, that kind of golden one, a lot of the bright stars that will be the pole stars, because they are the brightest stars near the pole. Remember how even Polaris made that little circle? It wasn't exactly at the pole. So a lot of these bright stars aren't quite on the circle. So this circle that we make in Western science isn't accurate. We act like it is. It's not accurate, but I'll show you one that is. This one's accurate. Doesn't that blow you away? The little ring of rocks up there is more accurate than the way we do our astronomy now as far as the precessional cycle goes. Look how accurate. Those are all pole stars at some time. And then there's Thuban. I want you to notice that again, because I just put the constellations. These are the International Astronomical Union constellations. So anybody who does work in Western science, even if their own culture uses different names, they'll often use these just if they're talking to an international audience. It's kind of like people starting to use English a lot in international audience. Yeah, but they have lots of names, and it's so cool. I spend time just learning names of stars because the names tell you a lot about what they do. It's very, very fun. At any rate, I'm getting off. So this is not a perfect circle, and it shouldn't be a perfect circle, because if it is mirroring that precessional circle, it has to look like that. So if you find a medicine that's perfectly round, and I could give you an example because I think it's North Dakota, I should know for sure. One of those colleges went and made themselves a medicine wheel, and they made it a perfect circle, and they made all those segments the exact same size, which immediately showed me they didn't understand the astronomy. So what they do have is they have a little equinox they do with it and a solstice, but they totally don't know all this other cool stuff. Sooner or later, I'll let them know. Just haven't got around to it yet. Okay, so there's our wheel that, you know, looks a little bit rough, but if it's thousands of years old, you know, how would you look, you know? Anyway, it's an awesome piece of technology is what I'm getting at. There's that alignment. Now where it's going through, there's the sun. The sun is a star, in case you didn't know. This is 2800 BC. Your guys' way. And even though it's a solstice, you might notice I'm saying it's July something. I actually can't read it. 19th, I think, 18th. The reason it's not June is because as you go different times and we have different pole stars, we're moving into that summer is winter, winter is summer thing. So we're going to start clocking around to where solstice is going to now be in July, and it's going to keep going. The farther you go back in time, the farther it moves towards December. And there's Thuban, that star I kept telling you to watch. So here we have a whole nother, I like to call it like a lock and key. We have another way to date this. And that's by this very processional circle design. Tells you, if I would have never went up there and did all of the measurements, just this design shows you where the sun would be. And you'll say, well, yeah, but I see the sun, I don't see a date. Okay, I'll show you how you get that then. Oh, this is just an extended version where I put you up into the sky and showed how it matched up. You can probably see the Deneb star where that white arrow starts. Still the same arc. I didn't point out Vegas so much to show you anymore. So I guess you'll have to trust me since I don't have a laser to show you where all the stars are. But anyway, here's the sky, only based on the design. Not based on that hole in the rock thing, just based on the design. If you follow those stars through up in the sky, it's telling you where the sun was or where the sun is when, I don't know if it was when it was built or just an important time, but at any rate, that's what it's pointing to. Oh, and then I just did this to be funny. Second star to the right and straight on till morning. See, we all knew that ahead of time. Now, the night we found this, or the early morning we found this, we told Bill Matthews, who was then the archaeologist that kept track of the wheel, and he knew we were up there, so I don't know if he called us that morning or whatever, but, oh, maybe he even came up. But at any rate, he was all excited. He's not an astronomer, but he could kind of catch what we were saying. There was this rock at a distance, and that it was, even though I'd been up a lot, because when sunsets and sunrises and getting up through all that snow and coming down, and we were all pretty brain dead, but I still just couldn't wait. And I did that math and all that. You saw the degrees and all that, and I worked on that. And because I just had to know, how old is this? And so I knew by morning it was somewhere around 3,000. Told Bill Matthews, and guess who the first people to learn of it? Until tonight. Actually, I might have told somebody in Cody last year. But anyway, the first people to know was the Sheridan's school kids who showed up that day on a trip. And I don't know, I've given you enough time to look at this. Maybe you guys recognize some of these people. I wasn't there. We'd already packing up our stuff down below and getting our gear put away. So I didn't even know this until later when Bill sent me the picture. But I'm so happy because look at, you know, the Sheridan kids, there have got to be descendants in there of some of the people that Greta herself taught. And for them to be the first ones to hear of just the amazing technology that this wheel is, that I would assume Greta knew. If anything I'm telling you is true, she must have known it too. Anyway, chills. Okay, that's one way of looking at the sky. I call it horizon astronomy. Obviously, you could see it also use the design of the precessional cycle, which you see in just lots of places, pretty much sky watchers. It's like if you want to read, you have to learn your alphabet. Sky watchers have to know precession to be able to do it. So that's just a fundamental. And that wheel shows that along with the horizon, stars rising. Okay, now off to Medicine Lodge. So you can probably find Sheridan up to the upper right. Burgess Junction, and I didn't put the Medicine Wheel on this one, but it's before you get to that alternate 14 where the yellow road kind of crooks around up there. So you're not quite straight south. I kind of checked that out. I just thought that'd be cool, but you're not. You're a little bit east of south of the wheel. About 50 miles, 47 miles. So Medicine Lodge Creek is a beautiful, beautiful place with some of the most amazing people taking care of it. If you ever go and look at the rock art, be sure you talk to the people that you see around there, the park employees and that. They're just amazing and wonderful. So you can't see from this distance too much rock art, but it is all over that thing. Thousands of rock art, all sorts of different types. And the ages are still pretty much unknown. They've dated a few of them. Here's just another picture. I wanted to point out, look at that upper sandstone. I'm not a geologist, but two different geologists told me that that could be stable for 10,000 years, easy. And it's a different kind of sandstone than the red-orange below, which is softer. That would wear off a lot quicker. And most of the rock art is in this red-orange. So let me do the complicated thing over to the right first. The way you do this meridian astronomy, that's the one we're kind of comparing and complementary to the horizon astronomy from the Bighorn Medicine Wheel. So this kind of meridian astronomy looks along a cliff at things kind of going right across that line from north to south that goes over your head, north to south over your head. And what happens is when the sun or stars or moon, I've gone out there and the moon will do the same thing that I'm going to show you the sun's doing. This kind of astronomy allows you to see how high things rise and how they arc across the sky. Now, during that same precessional cycle of the different North Pole stars changing, the stars and things will shift down and up. So you can see it from this too, but you're getting a totally different way of tracking it. And as you see, I've got 16 north. Probably a lot of you know that there's a magnetic offset. So if you use a magnetic compass, north isn't going to be north. See how the little ends to the left? You've got a, the magnetic's going to be a little bit off, and it's off differently in different places. So you always want to check. And if it's a place you do research like I do, you want to check over and over and over every time you go there, because the magnetic pole does not stay in the same place, as some of you may know. The medicine wheel is especially screwy because there's one part of the medicine wheel on the south side where your magnetics go crazy. And one night we had our telescope there, and it just put an arc of lightning through our telescope and burned it out. And then later, years later, I had my theodolite there, and the theodolite started doing some weird numbers. And I all of a sudden went, oh, and remembered where we were and grabbed it and went running off with it so it wouldn't ruin that too. But anyway, watch that, because so many old things with medicine wheels or wheels, they'll put a north on there and you don't know, is it a compass north? Is it true north? So if you're doing research, be sure you make note of that for the next researcher. Okay, here's another evidence of my use of graphics. So can you tell what's happening? We've got that hard sandstone on top, the sandstone cliff. We're kind of looking down from, actually on this one, we're looking north-south because, you know, the sun's a little lower toward the south in this part of the world. It doesn't go over our head like it does down other parts of the world. So at any rate, they've got trees on one side, and there's also cliffs over on the other side too, because we're on a creek bottom. There's cliffs on this side. So the part of the sky is the part above your head. But that's perfect. You can do astronomy there. In fact, you can do a really unique kind of astronomy there. It kind of made a murky sun shadow there. And it's actually two shadows that are going to make this shadow on this little petroglyph. I call him the have-as man, because you'd never call a lady have-as lady. So, but anyway, it's the as is for azimuth. Anyway, we get a better name. If you guys come up with something, let me know. But anyway, at solar noon, and that's when that noon is exactly in that line north-south over your head, when it comes right like halfway between morning and night, sunrise and sunset, which that really isn't that accurate. But conceptually, it's okay to think of it that way for right now. So basically, when the sun's at its highest spot on that day, you get these shadows. Now, right away, they're astronomical because you're only getting them when the sun is in one specific point. You get shadows kind of a little bit later and earlier on other things, and they look kind of artistic, but this one has a definite use to play. There I am happily finding it. The reason I even found this at all is that a Greta had said, if you want to know about our people and our history, go down to the art. I don't know if she called it art, the painting, the writing, and it's all there. Well, I went there and I couldn't make sense of it at all. So I thought, okay, I'm going to sit down and just flush out my brain, see if anything just comes to me. I mean, I'm in the environment. She seemed to think, she was telling this to a guy who was a white guy, Denniston Billings. He'd written some books. He'd helped the Crow Indians by going to DC, and he's a real, love to be out and hunt and all this. And he saw her, she is so old, and he just thought, oh, she must have stories to tell. So he interviewed her. So I'm just telling you that because she was translating through the Crow, who were translating the sign language. So any of the words I give you are his words. So we have to give him a little more, when she said, go down, you'll find out about me or about my people. But she knew how different his culture. So for her to even say you could know, I assumed, well, maybe I can know too then. So I sat there in front of that cliff, and this thing happened on the very I was there. So here's what happened. We only have a few slides left. I think we're out of time, and you guys can ask me lots of questions. Please make them hard. I don't, no, easy questions are okay. But anyway, look to the left there. The shadow, and this is not on the same day. These are, notice the shadow in the middle, there's two shadows. That in the middle is straight down where that line is. And then depending on the day, right at solar noon, it'll hit a different arc, a different arc, a different arc. And the bigger picture on the right shows it about halfway through this cycle, which turns out to have a lot of other astronomical things connected to it. This is a movie of it happening. Now get ready, because some of the people that watched it call it watching paint dry, and this is a speeded version. So you really have to let yourself sink into this cliff time. Now watch when it completes the circle, it actually cuts it off right at the circle too. I'm just going to go do that now that you know it's doing it. The time we try to clock the time on is exactly when that half is full to the half, and then see where it is on the other side. Now those arcs look like they're random, but just like the wheel, they're not random a bit, because whatever it's using to make a shadow, it's about every 2 to 3 days, it'll hit one of those. And this can actually tell where you are in the leap year. This little petroglyph can tell you better where we are in our orbit than those calendars hanging on your wall. So see, you can't count it yet. You got to wait there. Got to wait till it's lined up with that middle one. So if you ever go there and see this happen, it happens between about August 10th and 14th maybe, and the end of the month. So what's really nice about this kind of technology is if you have 2 weeks to see it, and because there's all those arcs, you know where you are in the 2 weeks. So it's not like a one-time thing. I missed it. I guess I don't know what time of year it is. You can tell, oh, we're already to the 4th line. And it's also connected to the moon cycles, but I think that's too much to throw at you guys all at once. So obviously we could do several Zooms just on this one petroglyph. And he's one of 4. You can kind of see some other circles next to him. I don't have a picture of how fun those other guys are, but they're really cute. Now, the half-as, or the XAF, cross-azimuth petroglyph, the one I just showed you, is when the sun rises. Well, I should say, since we're talking about the meridian, when the sun is halfway up in the sky from its highest point at solstice to its lowest or its midpoint at equinox, when it's halfway between those, that's when it did what you just saw. This half happens when you're half the way in days between the equinox and the solstice. So once again, you have a complicated technique here, technology for keeping track of multiple things and doing it really well. Oh, because maybe you didn't know already that the days and the azimuth aren't the same. Oh shoot, I probably really screwed you up. Sorry. I just threw this in for fun. Only I say fun, it's tremendously serious, but it's also tremendously complicated. It has to do with how fast our Earth spins as it goes in our whole orbit. We don't always have 24-hour days. We have shorter days and longer days. And this petroglyph tells us right there, right at that crossover point, that's where it tells us where we are in our orbit. We're at the point when our 24-hour days are balanced. It's another halfway. And the reason those lobes are longer and shorter is all a wonderful thing to figure out. That's called an analemma, if you've never heard one. Here's just the research that helped me with this, but I'm not going to hit it too much unless you guys are interested. But what that petroglyph also shows us that would be important to the people living there would be when that thing does either of the 2 things I just showed you, because they're not that far apart in time. One's on the 7th, and then that other one starts on about the 10th and goes through the rest of August. Either one happens, you know, climate is changing or weather is changing fast. The sun angle's changing fast, moisture's increasing, which means more snow up high, up at the Medicine Wheel. If you're living up there, see how little guy's feet, they're pointing south. It's like time to go south. I'm just making that up, but it is fun. His feet are facing south. Way back, this guy, just one fun thing before I end here. I didn't tell you about that central cairn. I did tell you that it was the center of the processional cycle, or maybe you could just tell that, but there's actually air in the sky. I can just hear you going, ooh, oh, that's NGC 6543. Easy to remember because it's 6543. It's also called the Cat's Eye Nebula, but oh, I'd love to know what, you know, some indigenous nations call this. You could actually see this blow up. It probably blew up in about 1200. And I just showed you the center. That's the fuller. Fantastic, huh? I wrote a story for my Yellowstone star map about gem at the center of time, and this is the gem. It's also that center, sometimes called the central fire, and that processional circle of stars is called the council, sitting around the central fire. And as time goes by, different people in the council or beings become the pole star. And then there's different things that happen when they're the pole star. So you can see how this turns into stories, but it's straight, wonderful astronomy too. Here's my research team for the field. Great people. That's Jack Robinson down the bottom that is no longer on the planet with us. He might be out there in that nebula. I'm dangerous to be alone and not see my people I'm talking to. Okay, here's that book I had Sarah take to Sheridan. There might be some copies around. This is my thanks, and I want to thank the wheel. There's a picture of it. It's taught me more than any textbook ever came close to teaching. When you learn about these things, those textbooks are almost useless and can really get in your way. Mostly you're comparing the patterns on Earth, the people left, to the patterns in the sky. And where you don't have a culture to tell you what happened up there, that's what you have, is the patterns. And they either mesh or they don't, and they mean something or they don't. Bill Matthews, that's the fellow I told you about. And then there's the whole list of other folks that I'm very thankful for. And that's the end. Should I stop
Hooray.
sharing?
I'm cheering. Ivy, that was fantastic. Fascinating.
Oh, good. It's so hard to talk to a quiet audience. Am I the only one laughing?
Yes. No, well, there have been comments in the chat box, and
Excellent.
most people are thrilled. Everyone, well, the comments that are coming in now. So thank you very much, first of all. And I'd like to convey any questions that come through for Ivy from the Q&A box. I'll read the first comment that's there, and then we'll read what comes in. Hi, Ivy, congrats. It was excellent. I wonder what kind of material culture have been found by archaeologists in those archaeological sites. Thanks, from Argentina.
Oh, Argentina. You know what? There is a nice big book about, I didn't even say anything about the archaeology found under the petroglyph. And that is one of the oldest and continually lived in places in Wyoming or that area. You know, I think it goes back 10,000 years. So that's worth looking more into. Yeah, I can't remember some of it that I would want to tell you, but yeah, tons of stuff. In fact, they found something that when I looked at that petroglyph, I thought, you know, to keep that real steady though, so that when you looked up at stars in the sun, you'd need something that just your head was locked into one place, right? Well, one thing they found was these big slabs of rock that looked like a chair to me, but they didn't know what they were. So they literally backhoed them. They're still there somewhere. I'd like to do a dig and go find them. But they thought, well, it's not a hearth. I don't know what that thing is. And it was in the perfect place for a seat to do this astronomy there. But anyway, they found tons of stuff there. And my friend, who I'm figuring that is, who's asking that question, just email me and I'll send you the name of that book and maybe even some of the pictures and stuff. But yeah, tons of stuff. That place is worth visiting.
Neat. Another question, have you ever done work in Machu Picchu?
Let's see, I'm trying to decide what work I've gone down there and studied it, but I have not, you know, done my own research. I just looked into an idea somebody else had about some basins being filled with water and those water reflecting stars, which is a good thing for all of us to think about too. When we find basins that don't look like grind basins, water reflects stars, and you can analyze angles in a thing of water just like you can the whole sky.
Neat. I've got another side question, Ivy. In addition to the site near Hyattville, the Medicine Lodge Archaeological Site, were there other rock art sites in the area that also pointed to information that tied to Medicine Wheel?
Yeah. I mean, it was really, the hardest thing about this talk is what don't I tell you, right? Because I mean, we could all just keep learning, keep going and going. Yeah, there is tons of good stuff. There's even a rock art that I haven't visited, but it's on my list. I've seen pictures of it where it looks like the fellow I just showed you, but his feet are pointing north. And he's not on the east side. Is that how it works? He's on the other side of the cliff that he's on. It's a north-south cliff too. So totally ready to go look at. But there are people who are spending a lot of time doing that. I just don't have time yet. I've spent years and years and years on these two sites.
Yeah, right. Amazing. And yeah, what you've uncovered is I love the discovery of the cairn or the hole in the rock 4 miles away. That's
Isn't
so
that
cool.
unbelievable? And
So
we
cool.
almost didn't go there. And I just said, I cannot leave this time without finding that. I have to. And I'm so glad we did.
That is neat. I've got a participant, Loretta Owen. I'm going to unmute you, Loretta. It looks like you might have a question. So let's see if that's going to work for a question. Let's see. I'm not sure if I can do that. No, sorry, Loretta. I don't think that's going to work from my end. Here's another question from Andrew. What are your ideas on the magnetism at Medicine Lodge that destroys equipment?
That was actually at the Medicine Wheel, although I don't doubt there's some there too. What was the exist again? What were my thoughts about it?
Yeah, so what, let's see, what are your ideas on the magnetism?
Oh, ideas. Okay. Oh, that's always the scary thing. Well, from other sites and other things that have been studied, that magnetism happens a lot in sacred sites, and it can affect our magnetism. And one guy that was just a science guy that was brought in to look at some sites, and I can't remember his name, he had a magnetometer and he'd be going along and then it would do something weird and he'd stop and look around, and invariably there was always an offering or something right near where these little magnetic, I guess I call them anomalies, but they're probably the opposite of an anomaly. But at any rate, I think there's definitely something about magnetism in sacred sites, and it's not my field. You know, I'm always looking up at the stars, but I think there's so much to be done on this that if anybody's interested, I think that would be well worth studying. Also, I can tell you that after I did that ceremony that the elder gave me, it was in that exact spot with that magnetism where something so scary happened that it took me a while before I wanted to go back to the wheel. And I know here I am in academia, you know, and my other PhD buddies that are trying to get PhDs, they're like, oh, you're going to go to the wheel. Yay, get out in the field. This is going to be great. And I'm like, no, it's really scary. I don't want to go. So I literally had to overcome my fear to go back that wheel. And somebody asked me later, they worked with energy groups, and they wanted me to go up there and guide them or something. Well, number one, you're not really supposed to guide people, at least not for money at the wheel. But I said, oh no, you don't want to take a bunch of people and play with the energy up there. You know, like, no. I had way too much respect for it. So I'll leave it at that. I have a lot of respect for it.
All right, another comment from Shayla, who has kids who are age 10, 12, and 12. Would you please tell us more Agreda stories?
Well, the fun one, the quick one, they're a little longer in my book. And actually, if you email me, I'll just send them to you. I've got them in PDF. But the quick one is, and your kids would love this. I love it. And I'm about their age. So she went up there, Agreda went up there to pray. Remember that steep cliff and everything? And it's that way on a couple different sides. So she went up there to pray. I don't know what she was praying for. But she was gone quite a while. She was about 16. And her boyfriend started going, ooh, she hasn't come back. And the clouds were coming in and everything. So he went to just figure, I better just go up, see if I'm not in trouble and whatever. Well, on the way it started snowing, he saw her prints when he got near the top. And then he bear prints on top of her prints. He didn't know if she knew there was a bear right behind her or what. But anyway, he gets up there and she's actually in a tree, which is interesting because right now the trees are barely getting big enough. Again, you could get up in them. So it kind of gives us an idea that there were probably taller trees when she was there. Or maybe she ran down to where there was a tall tree. I don't know. But at any rate, she's up in the tree. He tried to kill the bear, you know, bow and arrow and everything. And it's really fun. You hear the story. And I mean, Agreda told the story. She's 115 and she's telling this exciting story about getting one arrow in the bear and then the bear goes over the side and, you know, and he gets another arrow in the bear. Finally, Agreda comes down out of the tree and helps him. I don't know how, but at any rate, he finally gets an arrow that kills the bear. And when he pulls it out, it was right in the heart. When he pulls it out, it was just bleeding. Well, it was dripping blood. And Agreda made the point of saying that this young man never done anything to be worthy of a name. He was still just called so-and-so. I think it was Red Plume was the chief, Red Plume's son. And so, you know, and you know, you're 16 or older and you don't even have a name yet because you haven't distinguished yourself. So as soon as he pulled that out, Agreda called him Red Arrow, and it stuck. Anyway, next spring, which would have been a little, probably 6 months later or so, they got married up at the wheel. And she tells about, you know, how the tribes walked along the wheel and who sat where. And she called the cairns different names. I couldn't remember right off. I remembered the middle one was the Sun Chiefs. But anyway, people took up places in it. And then, of course, if they all gathered there, they had to know when to gather there, which means they had some kind of calendar to where they could all get there on the solstice and have that celebration. So that's just a little taste. Kind of sad to think that later that same husband and any kids she had with them died of smallpox. So crazy life she lived. I mean, I really honor her. Wow.
Neat. All right, here's a more maybe scientific question. Could you clarify the solar interaction with the lines in the petroglyph after the cross-quarter day?
So what the little arc lines would mean? Or I wonder, not totally sure I know what that question means.
Let's see, clarify the solar interaction with the lines in the petroglyph after the cross-quarter day.
So like this one, am I still screen sharing?
I don't know if, yeah, I think you are, yep. So
okay,
we can
so
see it.
this is the cross-quarter day, unless that person meant the cross-azimuth day. I don't remember, yeah, I do remember. That line just stays a line. Remember how the other one had two shadows interacting? This one, I believe it's just the one shadow and it just goes across the face. All it does is say, hey, half time, and it keeps going. So I don't think those little arcs do much more. And the little people that are to the right, you can kind of see that next guy over there. Well, I guess I can see him because I'm used to him. He has horns and he's really cool. He has like buffalo feet or something. I've been working on those other three. They look like they were all pecked at the same time. So, I mean, this is wide open. I took a few friends, two friends, Amiel, the one that helped me, he went down, and his sister's an artist, she went down. I thought Hayes might see something. He's an end, he might see something. Everybody found really cool things that happened on the equinox. I'm always so busy looking at this one, I can't look at the rest of the cliff. But Amiel actually caught a shadow being coming out of the cliff. And what that means is you have a cliff face that just looks like a cliff face. And at that moment of solar noon, and I think it lasted 2 minutes, just came out of the cliff and looked at you, and then it disappeared. It was really something. And it only did it 2 days, and 1 day better than the other, and that's it. And it did it right at the equinox. So that was an equinox one. Sorry, this is a cross quarter. So ask that person can sure ask me to clarify if I didn't quite answer what they wanted.
Okay, and that was from Gordon Houston. We'll see, maybe.
Oh, Gordon, that's a good question.
Mm-hmm. All right, well, maybe, let's see. I think that for now, that may be, let's see, I have another question. I assumed as well that the crossover point of an analemma was at equinox. I was fascinated
Everybody does.
Okay, I was fascinated to discover recently that it's not. The equinox is literally midway through the analemma, not the intersection. That's a comment from Chloe.
Oh, Chloe. Oh my gosh, this is great. I'm glad I didn't know you guys were on this. I probably would have been really nervous. But yeah, that analemma, I'm trying to find it actually, but my thing keeps messing up. Yeah, that analemma is, you got to watch some of this stuff because it gets copied and they act like nobody really cares, and it's copied wrong a lot. And so a lot of the stuff that helps you with sky watching, you've got to recreate it yourself to even know what's going on. Yeah, she's right. A lot of things are labeled, that's the equinox, and I thought so too, until This petroglyph, see, the textbooks were wrong. This petroglyph taught me that that is not where that analemma crosses. And a lot of the stuff on the web is wrong. Even Wikipedia is wrong on that one.
Well, I'm going to thank you from everyone that beamed in. We had 85 people that listened to the lecture tonight. Thanks to everyone who joined us. And what a great thing to learn more about our own backyard. Thanks so much, Ivy. That was just really fascinating. And I'm hoping some of us will reach out to you and continue to learn from you in the coming days, months, years. We'll see.
Yeah, and I'm sorry, I don't think I put my email on here, but it's at Gmail, so that's easy. And it's just my first initial I and my last name, Merriot, with 1 T. And feel free to help me, ask me, critique me. Love it all. And thanks for joining me tonight.